Okay, lesson 3 is a little bit of a review and a little bit of new stuff. We are doing square roots and cubed roots. So we already know that squaring a number is raising that number to a power of 2. When a negative value is squared, which we learned last unit, be careful to note whether or not the negative sign is inside parentheses. So remember the differences in this. We have -2 squared, so that's going to be 4. -3 squared is 9, and so forth, because it's -2 times -2. Over here, squaring a number is the inverse. Whoops, sorry, got ahead of myself. Over here, this is 2 squared and then the opposite of. So opposite of 2 squared. So that would be 4, and then we bring in the negative. And again, that should be a review from last lesson. So squaring a number is the opposite, or we can use the fancy term of is the inverse of taking the square root. So just like subtract and add are kind of like inverse operations, multiply and divide are, so is squaring and the square root. So when we take the square root of a number, technically results in 2 solutions. For example, the square root of 16 is 4 is what you normally think of. But it could also be -4 because 4 squared equals 16 and -4 squared is also 16. So it really could be either one. So the positive square root is known as that principal square root. So when we use the square root sign, the solution is the positive square root. Cubing a number, or raising a number to a power of 3, is the inverse, so is the opposite of taking the cubed root. And this is what they look like. So it says the cube root of 8. So for example, the cubed root of 8 is, so you can do it on your calculator, but you should be able to try to figure it out. It's a number times itself and times itself again for 3 times. That is going to equal 8. So pause if you want to try to think about it. And the answer is 2. 2 times 2 is 4, times 2 is 8. So could a cubed root ever have a negative solution? And what do you think? So could we say like -2? No, because -2 times -2 times -2. These two are 4, but whenever you multiply by that third term, it's always going to be a -8. So it's going to be a no. Okay, so complete the tables below for the first 10 perfect squares and cubes. So we know 1 times 1 is 1, and we should know these from last unit. You can go ahead and just copy mine, try to think about them, or use your calculator. 64, 81, and 100. And you know they go on forever. Okay, and then the cubes are 1 times 1 times 1, 2 times 2 times 2. Now these you probably don't have memorized, and so again you'll be able to use this. 125, 216. I think that's about as far up as I have memorized. 512, 729, and then of course I have this one memorized. Okay, so we're gonna learn, knowing that stuff, we're gonna evaluate just like we did in the last unit. But now we're just adding in cubed roots also. So go ahead and pause it and see if you can come up with the right answers. Okay, go ahead, and if you need to pause it to look at my answers to see what I did. The fraction one always messes people up, and it's really just that fraction times itself. This is where you can take the square root of each number. Whoops, I didn't mean to put the square root. Okay, well, we'll put a 4 there. The square root of 4 divided by the square root of 9. So you separate them and get that. Okay, square root of 49, we know that 0.7 times 0.7 is 49, and then we move the decimal back 2 spaces. This one, square root, and then you bring the negative sign in. If the negative sign is on the inside, you cannot do that because nothing times itself will ever be negative. Okay, and then let's go ahead and evaluate the cubes. So those should be easy, especially if you use your chart from the front side. So go ahead and do those and pause. Okay, and again, you can check out the work. If the exponent is an odd number, it's always going to be negative. Sorry, I should say if the base was negative. Okay, here the 1 stays because 1 times 1 times 1. And same thing, here we have a negative that's outside of it. So we do 10 times 10 times 10, and then we bring in the negative. We can use a chart for that one, 6 times 6 times 6. This would be 8, and then you bring in the negative, and this you separate them, and the cubed root of 1 is 1. Then you have to find the cube root of 27. So if we look at the story problems, a set of 121 chairs needs to be arranged in a square formation. So square makes you think of square root. How many chairs should be lined up in each row? So if there's 121, then we know that each side would be the square root, so it would be 11. Okay, volume. Volume is of a three-dimensional object. So it's not like a flat thing on a paper. It's like a cube that you can hold in your hand. So it's always got the label of cubes, like inches cubed. So you need to find the length of one side. So since it's volume, you take the 729 and you find the cubed root of it. So you either use your chart, or if you can find the button on the calculator, or you can make guesses. Like you could do, 11 times 11 times 11 and see where you're at. And then maybe lower it and keep going until you find the right answer. Once again, please practice on the homework page.